All right, in this exercise, we are going to apply a horizontal scale factor to a function. The function is y equals x cubed, and the horizontal scale factor that we're going to apply is the scale factor of 3. Now, I've already pre-drawn y equals x cubed. It's a cubic. There it is right there. Many of you have seen that style of graph before. Y equals x cubed. What we're going to do is we're going to apply a scale factor of 3. Now, what does that scale factor actually mean? It means that it's going to be 3 times as wide horizontally from left to right than the original parent function, which is y equals x cubed. So I imagine with a scale factor of 3, by a factor of 3, if this is here, it's going to be pushed out 3 times as wide as this is from the original y-axis. So if it goes out this way here, it's going to go this way out there. So you can imagine this being pushed out and becoming wider horizontally. That's what's about to happen. But first, let's actually write up the function of what it's going to be written as when we apply the scale factor, horizontal scale factor of 3. So here's how we do it. We're going to use this system here, where we replace the x value up here, we replace the x gets replaced for x over the scale factor. You replace x for x over the scale factor. So that means this is going to become y now equals x over the scale factor. The scale factor happens to be 3. So this gets replaced by x on 3, which means all of this is still to the power of 3, because that's to the power of 3. So the whole thing in there used to be x, now it's x over 3. So that is our new function. Very important that we keep that in parentheses with the power of 3 outside. So that's our new function. Now we're going to draw it up there. So one of the best ways is to draw a table of values so we can take a closer look at how horizontally, how much more it's been stretched. So I'm going to put the table of values here. So the values we're going to have is going to be the x values, and we'll have the x over 3 all cubed values. So let me just I'm just going to go from 1, 2, 3, 4, possibly 5, and whatever happens up here will happen the exact reflection down here symmetrically. So let's go say, well, 0 is still going to be 0. I'm not going to put 0. So let's put 1, 2, 3, 4. I think that will do. Okay, let's start putting some values in here. So you can use your calculator. 1 replace x with 1, put 1 into there. 1 over 3 is 1/3. 1/3 to the power of 3 on your calculator is going to give you something like 0.03 approximately, because we're just going to put on the graph. Let's take 2, put it there. 2 over 3 is 2/3. 2/3 to the power of 3 on your calculator is going to give you approximately 0.3. Now let's put in the value 3. 3 over 3 is 1. 1 to the power of 3 is just 1. Now 4. 4 over 3 is 1 1/3. 1 1/3 to the power of 3 in your calculator is going to give you something approximately 2.4. So that's going to give us a good idea of how much wider it's going to be than the original parent function. And of course, we're guessing it's going to be 3 times wider. So it's going to be 3 times out that way. So let's see if we can join the dots here. 1, 0.03. 1, 0.03. It's very tiny, just down there. Then we got 2.3. 2.3 will be approximately there. We got 3.1. 3.1, that's right there. And we got 4, 2.4. 4, 1, 2.4 is right there. So let's join the dots on that. So this is going to look something like this. There's our graph. All right, now it's going to be a reflection down here, so I'm going to estimate it's going to come across approximately like that, right over there. Okay, there's our new graph, and this new graph is y equals x over 3 over 3, x over 3 to the power of 3. All right, so let me just write that down. So it's y equals x over 3, the whole thing in parentheses, to the power of 3. All of it is in the function. Remember that 3, that denominator there, is this guy here. It's the horizontal scale factor. So there it is. It's a lot wider. It seems to be 3 times as wide, but let's double check. Let's actually see this and confirm it on the horizontal plane. So I'm going to pick 2 points and see if they're 3 times wider. So let me just put our point, pick a point here on the original parent function here in red. So let me just pick the point 1, 1. That's easy right there. And now I'm going to find a point on the same horizontal line going through the new function, which is right there. There they are on the same line, same horizontal line. So let's measure. Now the first one is 1 unit away from the y-axis. So horizontally, it's 1 unit away. Now for the second function, right over here, let's count 1, 2, 3. It's 3 units away from the y-axis. Clearly you can see that the new function of x on 3 all cubed is 3 times wider than the original parent function right over here. And there you go.